GOF 2.0 is a SESAR project. It's a successor to the previous project, which was the GOF 1.0. And in GOF 1.0, the focus was very much on demonstrating integration of use space in ATM, in trials with manned and unmanned aircraft operations. Now, in GOF 2.0, this project, the focus is going to be on safe, secure, and sustainable integration of unmanned aerial vehicles and air taxi operations in urban airspace. A bit of a mouthful, I understand that, but I think the key area that the project is going to focus on is on demonstrating how highly automated real-time separation assurance can be achieved in the dense airspace. Now, with the use space regulation recently released, I believe we are in a very, very interesting area right now and time right now for use space and drones in general. But there are a number of challenges, no doubt, and throughout the course of this webinar, we will try and tackle as many of those as we can to meet our objectives that you see on the screen. Now, there's a need for the digital infrastructure to be created, and that digital infrastructure can help us safely integrate drones and eVTOLs in the airspace. Now, this infrastructure will be multifaceted, and it will contain infrastructure on the ground, infrastructure on board the aircraft, the communication C2 infrastructure between the aircraft and the ground, and we'll be hopefully using the cloud in future as well to try and make the communication, and many, many more other facets. The question that we are going to argue throughout the course of this webinar is, how can artificial intelligence help us in this integration? Can it enable safe and secure separation, and particularly in dense airspace? Many technical questions that will come and go, and you probably have heard from other webinars and conferences so far, but there's an interesting angle that we'd like to bring as well, which is that we need to have a competitive business case for flying UAVs and eVTOLs in urban environments, dense urban environments. Now, what are the challenges to have that? Can artificial intelligence us in achieving that competitive business case? Quite frankly, if we can't achieve that competitive business case, then we're not going to go too far, are we? ANSPs have a particular challenge here to integrate the drones in the airspace that they manage, especially whilst collaborating and sharing the data between the drone and the ATM world. The local cities and municipal corporations currently are seeking help on how best to start implementing drone operations in urban environment. Now, in all this, there's a very specific role of autonomy that needs to be played, which should take us, and I emphasize, should take us from the current setup of where we are talking human to human to a future setup where we are talking system to system. Now, this is a huge change from today to tomorrow, and we will need to understand how best to manage the change. Now, to help me go through and explore these areas, I have four very intelligent and esteemed colleagues and professional associates. I will introduce them one by one, but they are Gunther Graf from FREQUENTIS, Andreas Perotti from EHang, Ivar Vark from the Estonian Air Navigation Services, and Jonas Steinberg from Roberts Expert. What I'd like to now open the Q&A session and have an interactive discussion with our panelists. Whilst we wait for your questions to appear in the chat box, I'm going to kick it off, and I'm going to kick it off first with Ivar on a very high-level question on. I think a lot of people have been participating in a lot of these webinars, and many discussions are ongoing as such. But just to set the record straight, could we first identify what you consider, Ivar, are the biggest challenges today for ANSPs in enabling safe drone operations? I'll ask this question to Ivar first, and then followed by Gunther after that. Over to you, Ivar.
Yeah, thank you, Munich, for the question. Why and what's the biggest challenge? It's always a good question. Why? Because the actually economy forces it to do, because we all see that this is the way ahead. And how do it safely? It's I think in my mind always been that we need to digitalize first the ATM systems to make them closest to possible, to enable the AI to set in and start predicting the flows of the traffic, and start predicting the flows of the possible future traffic, and start predicting where the drones might be, where the actually manned aircraft might be, and actually alarm it early enough to make it all safe and make the safe decisions. Because this is the most paramount, that we need to have the safety of the space that it would work. I think that's the main, in my mind.
Thank you, Ivar. I think no doubt you've used the word predictability both in your presentation and now as well, and I think that's very key. In order for us to achieve safety, what we don't want are surprises, and what we do want is predictability. Good, from an OEM's perspective and the work that you have done and are doing with the NSPs, would you like to share your views on the biggest challenges to enable safe drone operations, please?
Yeah, I mean, maybe picking up on the predictability thing, yeah, and there is a big assumption, or that we have to discuss is, first, do we need a traffic management, or do we need somehow to monitor what is going on in the air? Yeah, because theoretically you could say, okay, I don't need traffic management at all. Yeah. The aircraft just should separate themselves. Yeah? And I think based on what we know, this won't work. So we need to have some sort of traffic management. And if so, traffic management is some sort of digital twin, yeah, at the ground, because we need to have a common situational picture. We need to know where the aircrafts are and where they will fly to. And then apart from all things, when we talk about AA and the automation, is how do we get all those data accessible, and how do we store it and have it available to make this automation? And then my conclusion is I need to have first a very broadband data link and a reliable data income, so where I know what the aircraft is or the drone is planning to do. Yeah. However we link that together, this is not yet 100% clear. The use-based regulation somehow points a bit to that. But if we do that and we think about some 100 autonomous vehicles flying around and then at the same time, then we have to have quite some computing power at the ground to really, let's say, predict the next minutes of traffic, next hours of traffic, and do all these deconfliction states. So I think there is some long way to go, and there will be a lot of steps. Comparing that to air traffic, it took decades to create the air traffic system. So we want to do that a bit faster for urban air mobility. But this, for me, at the end, is really how do I get all this data that is created already today by the drones into a ground monitoring system and combine of each drone the data together. And when this is given, then I'm quite sure we need to have AI tools to manage all this data and then get the right decisions. But what would be right decisions is just to say, okay, this drone is allowed to fly. This drone needs to have another path because there is no airspace available, stuff like that. Or here and there is a big gathering of people, so I don't want to have drones fly above that for risk or also for disturbance reasons. So my point is, how do we manage so many traffic data that would occur, and how do we intelligently also structure that? Because this is what we currently start off, and by the way, is also one of the topics of GOF 2. Yeah.
Sure. Thank you. Thank you, both of you. I think it's very interesting what you highlight jointly is current infrastructure we have to deal with the current ATM is insufficient to deal with many drones flying in the air, because there just isn't enough computing power there. There isn't enough capacity. So if we don't want too many drones, then well, we don't need to do anything. We don't need to do use space. But why do we need to do work with use space, and why we need artificial intelligence to help us separate the drones is because we think there's going to be many drones flying in the air as such. And once we have that digital infrastructure, which is suitable to fly them, I like the view that you've presented, Gunther, where we then need to identify what kind of data flows we need to gather and how to store them. Perhaps in future we might even need some kind of data governance, because if you're storing them, which data to use where and all that, this would be interesting. With that in mind, let's move on to taking that topic one step further. Now, looking at more close to the vehicle itself. And I'd like to ask Andreas now. Andreas, you talked about the need to have a competitive business case and the need to integrate various aspects so that the ATM and the use space start talking to each other. But how much integration do we need? Do we need 100% integration and only then can we start, or is there a step-by-step method to go from where we are to there? Any views on that, please?
Thank you very much for that question, Yunish. I also would like to comment on two previous statements, as we want to have a bit of controversial discussion here. You know, I think that generally speaking, even if you would take out the whole story of drones and say only the classical aviation is existing, ATM is at its limits, and we can see that in the daily life, and we can see that in discussions with single European sky and whatever. Meaning, even if we would not have the whole topic of UTM and U-space and drones, I think some digitalization and automatization would be necessary in that field. That's very clear. On the other hand, I fully agree with what Günther has been saying, with the amount of data, with the volume, with the proper categorization and all of that. But I do think if the digital community is looking at our debates here, they start loving about us, you know, because there we speak about IoT, about connecting millions of things in your household, in your daily life. So the techniques are basically there. I fully agree. Aerospace is a different thing. Aerospace is a different level of safety. Aerospace is a special category, or general mobility. It's nothing different in the car industry. They have a lot of similar questions like we do, but I think all these aspects are solvable. But it's great to have the debate and the discussion. Getting back to your specific question about how much integration is necessary between ATM and UTM. Well, actually, at the layers where they meet, and where are the layers where they meet? It's basically the interaction with the area of helicopters, thinking about blue light organizations, from the Red Cross to the police and so on. But here I think that's not too difficult if you find a mutual standard of how of detect and avoid. And of course, you can say that you have layers where ATM and UTM meet each other close to airports. But here I think that's just in theory, because in practice, UTM operations anyway will not take too much place close to airports. Yeah. And if so, in a very segregated route, because on the other hand, of course, we are discussing a lot of use cases in people's transport, on transporting people to airports and from airports, also cargo cases. I'll give you an example. We have a very close collaboration with one of the leading airports worldwide, where it's for medical use cases, actually, and where they're getting organs for transplantations to save the life of people, and they're arriving by air freight, and then they're delivered today by a Volkswagen Sprinter. Depending on the traffic, it takes them 60 to 120 minutes arriving at the hospital, where every minute counts. Here, a route which can bypass the traffic with drones can really save lives. So there will be also touch point with airports, but I think to a limited extent.
Thank you, Andreas. A very interesting dimension. I think you've introduced something that I'll come back in a minute. You also introduced the comparison with cars and automotive industry. Let's take that one later on. I'd like to bring Jonas now on to my next question. Jonas, we've just discussed, well, at least some of the challenges or problems that we have today to modernize the ATM infrastructure to help us for future integration with the drones as such. Now, with all the new regulations that we've got and stuff, where do you think we are as an industry? The US space regulations just come out. We are just going to start to utilize that. A lot of people will probably still need to understand its implication for implementing it before we go any further, and they need to be adopted by January 2023. And with the needs to modernize the ATM infrastructure, where do you think we are currently in this situation, please?
Thank you. That's a great question. And I'm going to jump on Andrea's strategy here and commenting on the previous speakers' views. I sometimes come across the view from ATM operators that they don't really want to see the drones, and when we talk about drone operators, they really want to see the manned aircraft. So we have two different approaches to this here. I personally never understood why we need to make a sharp distinction between manned and unmanned traffic. The way I see it is we need to make a distinction by performance and airworthiness and the skill of the people, because there's no point in mixing aircraft, one moving at 100 meters per second and the other one 10 meters per second. There's no point in putting them in the same airspace, because that's just plain dangerous. It's like you don't allow bicycles on a motorway either, for a good reason. It's the same kind of reasoning. So when we come to airports, the way I look at it is like, just to pick on one point here, is that there's a multitude of drone applications in the airport environment, from instrument inspection, from runway inspections, from taxiway inspection, traffic monitoring related to parking in the airport area. We have drone logistics, want to be in and out of air cargo terminals, balancing on the edge between the clean and the dirty area. Those of you who don't know that, the clean areas where you need to check in through a fence and know that you are security screen, and the dirty areas outside the airport. So there's a lot of questions related to it, but a lot of business and operational effectiveness potential in any environment. So I'd like to turn the question rather to a performance based and airworthiness based question. And so, but coming back to your question, where we are with U-space regulation and what that would mean for the whole situation, I think that we need, as Günther said, well, we need data, not control of necessarily, but we need data from all air vehicles in controlled and uncontrolled airspace. We have an aviation Internet of Things boom ahead of us, and in order to have an Internet of Things, you need each aircraft needs to be a node in that network. So we need to have a data link to all aircraft, and we need to be able to process that data. That's the only way we can move forward from a regime that is ultimately built on a see and avoid, when the human eye is looking out for other aircraft. And anybody who's been flying manned aircraft in general aviation knows that see and avoid also requires you to look out in order to see and avoid. And there's a lot of instruments and other things to follow in the cockpit. So that's broken already. And we talked about the strain that controlled airspace is facing in Europe. So the regulation would start with a segregation to establish a baseline to start working from and start learning. But we need to quickly step forward and update the regulation. I think GOF 2 is a perfect example of a way to make live demonstrations in an environment where we already integrated the aircraft. We have the air taxis, we have the drones, we have the HEMS helicopters, we have manned aircraft, and we're all going to mix them in the same airspace in a way that is safe by putting extra efforts on wrapping it in a safety network. That's what we need. We can't do this on paper or on webinars. We need to get the inspiration here, but we really need to go forward and starting doing it. So if we're looking at what does this mean for AI, we really can model how to integrate different levels of airworthiness and performance into the same airspace, where do we have the 10 meter and 100 meter per second question, and when can we integrate them? What kind of drones, heavy cargo drones doing 300 and 400 kilogram of cargo will probably move close to 100 meters per second, so why not integrate it? And I think that's also on the EASA roadmap for IFR flights and enabling that. And then the other aspect is how to integrate differently trained pilots into the same airspace. We have a hobby pilot and then an Airbus captain. They have a completely different understanding of the procedures and processes involved. So there again, for those who are not so trained, we cannot train everyone. There will be more drones than manned aircraft. We need to use automation there. And then to the GRAL, the first steps of use space regulation and establishing of use space is expected to be in densely populated in cities. But then again, the value add from use space is for beyond visual line of sight flights. But the regulation for airworthiness and certification comes only in 2023, maybe 2024. We will be seeing type certified drones capable of BVLOS flights. So we have a part misconnect here in the timing, but maybe only 1 year or so. But we will need to have AI and automation to do this in-flight tactical deconfliction, because when we get the ability to keep things separate in the air while they are in the air, doing all 3 levels of separation before the flight, on the strategic level, in flight with separation, and then even collision avoidance as the last measure. We need all 3 levels to be solid. Then we can have BVLOS flights reap the economic and the societal value that's associated with it. And we need to move quickly towards that.
Thank you, Jonas. Thank you for a fairly comprehensive answer to that. We have a question from the audience that I'd like to post to the panelists. I think it's best answered by Gunther, because it's really about the detailed techniques of AI and particularly explainability. So here's a question. It's from Javier Viana. Thank you, Javier, for the question. As you all know, evaluation and surveillance is essential in ATM. Nevertheless, most of the current widely used AI techniques are very opaque black box, which makes difficult for integration in aviation, as they do not allow the user to understand the decision-making of the machine. How would you bridge this gap in explainability, and which explainable AI tools, if any, would you advocate for? It's a bit of a mouthful, but see if we can get into any of those. We don't have much time left, only about 11 minutes, and I still have another 3 or 4 questions. Go ahead, Gunther.
I won't do a webinar on AI tools, but essentially that's the big point. I think what AI is striving, or what we can use AI for, and at the end it's a lot about deep learning when we talk about data and those tools, at the end is taking some of the decisions that today an air traffic controller, for example, takes very frequently, where the predictability is high. However, when the question touches on surveillance, the ultimately ATM is assuming that the pilot doesn't take any decisions on his own. He just gets directed, and I think that's the much more fundamental assumption that is in air traffic management. It will not hold for a UTM environment, which means that the aircraft is taking some decision at its own. And I think putting a regulation and assumptions around that is the big thing. And here I again come back to this very little thing of the data link. How do I get all the data so that I can trust the decisions that maybe an AI or a very long rule set in the aircraft or in the drone takes is not so important. But I think this fundamental change of, I assume that the drone can take at least some decisions on its own. This is the fundamental change. This can only be enabled by this technology of having all the data also in this observation system. And the AI in that case then is more the tool to enable to process all the data but not necessarily to take the decision. Because to be honest, we are circling around as a technology since 50 years about letting an AI taking decisions, and you all know these examples. And I'm not very positive that you will find somebody to sign off a type certification on drones taking too much autonomous decisions. But using AI to automate these decisions, that's something that might happen.
Excellent. Thank you.
Can I add to that? I think
Jonas, go ahead, and then I'd like to go back to Ivar after that.
Yes, thank you. I think that, you know, when you certify aircraft, you can either do that by deterministic calculation of how it works, or you do it by testing. And there's significant work undergoing currently that Robots Expert is part of. Specifically, my colleague Gokul Srinivasan is deeply involved in the standardization work. There's some AI tools available for explainability, like Lime and SHAP already, looking for specifics. And also Eurocai and SAI are working groups looking for the explainability of AI in aviation, looking at SIE G34 or Eurocai working group 114. So these are definitely pointers to look out for, but also feel free to reach out to Robots Expert for a deeper discussion.
Thank you, Jonas. Ivar, two very interesting views to highlight the importance of how AI can help a drone to become intelligent and take some decisions and take away some of that capability that doesn't exist as much today, because today, as Gunther said earlier on, that it's between the pilot and the air traffic controller. From an ATC related environment where you're sitting, well, I know you would like 100% deterministic technologies, because that gives you predictability as such. Where do you stand? How much can an ANSP really, I wouldn't like to say relinquish the control, but where would the ANSP sit in this discussion, please?
Yeah, really good question. It's never black and white in this case. I would say that, because in my mind always it has been that we are all moving this autonomous traffic conditions, so that some of the decisions are already made before the flight will commence, which means that those you can actually predict. But then it comes the manned aviation, which actually makes the changes in the flight patterns, and actually especially in those conditions what Andreas said, that especially in the close to ground where the helicopters and police are working, in those conditions it's really crucial to actually have this data available for all users. So I, in my mind, always think that I don't want to be the guy who is not letting this system to work, or I want to be an enabler. So to work ahead with this, that our system should be ready to integrate manned and unmanned vehicles to the same airspace. This is still a long way to go, because of every ATC is working with a different system, and the systems are not integrating really easily to each other. So this makes already the predicting very difficult. Because like Estonia, we are in the border of the EU and Russia, and all the information which comes from the West, it's easily usable, and we know it ahead when the aircraft will be in our airspace. But on the other hand, looking to the east, this is always some surprises coming, and you don't know so early as you wish to know it. So. And this is what we want to avoid, to bring the unmanned vehicles to the airspace, that we know what they are doing and why they are doing. And we don't want to segregate them, because this is not flexible use of airspace, and this actually puts a restriction to the service himself, because you don't enable everybody to use the airspace, because you're segregating it, and you're only giving the segregation to the some how to say organizations who are applying, but we want to give it freely to everybody and make it safely. I think this is the most crucial in here, how to make it happen. And like Gunther said, that the data, amount of the data is a big and enormous, and how to control it and make it work for the safety purpose. That's the question.
Excellent, and I fully understand, quite frankly, not just the technological challenge that you face in Estonia, but also the geographical. And thank you for highlighting that. And just for the benefit of the audience, at Eurocontrol, we're actually working with Estonia right now to help them do an airspace assessment. And it will be interesting to see what comes out of that airspace assessment, to see what the traffic is between coming from east to west, west to east, and how the traffic behaves differently. We did a similar one with Latvia and Riga and found some very interesting patterns. I'd like to go to Andreas as the last question before we wrap up, really, because I think Gunther, Jonas, and Ivar have set the scene very nicely, which is, yes, we can have the data available up front to do strategic deconfliction, because we have time for that. But when we get to hundreds and thousands of these drones flying in especially dense airspace above cities, and we're looking for tactical deconfliction, that's really the time when the question is going to come is, how could the artificial intelligence allow that autonomy to be built, where the drones can sense and avoid themselves, and the relationship between that and what the ATC people are controlling them. Now, from a vehicle manufacturer point of view, how important is it for you, particularly at tactical confliction management, for such an automation to be available?
You know, our technologies are basically able to have a detect and avoid when it comes to the let's say to the products which are manufactured and built from us. So I think the difficulty is not even in the layer of getting let's say different OEMs having detect and avoid in between the drones themselves. I think the critical question is the link to the ATM and to helicopters and to classical aircraft. I think that's the more difficult part. I mean, until we get to that scenario you were describing now, that we have 10,000s of drones up there, and these questions arise. I truly believe that we will get there one day, but I'm not sure if I'm going to experience it, even though I'm construction age 1985. But keeping it step by step, and you know what, I want to bring into the whole discussion two aspects, what also the previous speakers previously touched. First of all, we need to think global here. We need global standards. We are totally at different paces in between Europe, the Asian area, where mainly EHang is operating in the US markets. There is no national flag behind these technologies, and that's not what counts, because at the end of the day, why are we doing that? We're doing it to serve people, and we're doing it to improve our daily lives and give something back, what is the most valuable currency in the 21st century, and that's time, because we spend too much time in traffic jams and our logistic chains become more and more inefficient. So international collaboration, international standardization, I really urge for that. Otherwise, we end up in 20 years with the problems what the railway industry has today, that you have to switch the whole systems when you're moving through a border. And I don't want to have that. So that's point one. And point two is, what does it mean, AI? And we're always having this discussion in most of the panels I spend in a black and white manner. I mean, we always have this discussion of classical understanding of a pilot sitting on the aircraft with his gearing infrastructure and then piloting the aircraft around, versus the other extreme, the AI, this anonymous black box, nobody's knowing what's happening, deciding everything. And you know, there's a lot of in between. I don't think the classical pilot you can create a business case, while I don't think the full autonomy will be allowed in the next years from a regulatory point of view. Let's speak about automated AI assistant, and then all of this gets much more understandable.
Thank you, Andreas. And that really brings us to the end of this webinar. I'd like to thank all my panelists for a very thought-provoking discussion. I wish we had more time we could go into it, because things were just beginning to become very, very interesting, no doubt. But I think the key message from all of you is this: we need an infrastructure, digital infrastructure, first of all, to create as a basic, to expand the computing and the capacity backbone. Then we need to identify and select the right data flows, and identifying exactly how AI can help us to bring more autonomy, particularly for the tactical deconfliction, but not just for tactical deconfliction, because that's the safety dimension. It can also help us for air route management and for flight efficiency and many other areas as such. We need to look at governance of data, how to store data and what to do with it as such. We need to understand and manage the change that we go from today, where skills needed today versus the skills that will be needed in a more automated world will be very different. So many challenges, and the ANSP, no doubt, right in the middle, is trying to balance it from both ends. Whereas on one hand, they don't want to stop the economic growth. On the other hand, they also want to make sure that we're always safe in the air. That's the key. Safety. Safety is the key for any ANSP. Thank you ever so much, and thanks to all the audience who have listened to us. Should you have any questions, please come back to us. I think this video will probably be made available to you in a recording. And look out for GOF 2.0. There are some big things coming in this project. Thank you and have a good day. Bye-bye.